A 10 cm cube sample of a gaseous hydrocarbon is completely burnt in oxygen. The total volume of the product is 70 cm cube. All gas volumes are measured at room temperature and pressure. Which equation represents the combustion of the hydrocarbon? First of all, we see that in this reaction, the hydrocarbon is the limiting reactant and oxygen is in excess. So we can ignore any amount of oxygen used. Now we take a look at each reaction. Option A gives CH4 plus CO2 plus 2H2O. If we see that 10 cm cube of methane reacts, however, the moles of products formed do not correlate to the volume of gas used. The same goes for option B, in which we see that 1 mole of ethene gives 2 moles of carbon dioxide and 2 moles of water. Option C states 1 mole of C3H8 gives 3 moles of carbon dioxide and 4 moles of steam. So this means that if we have 10 cm cube of the reactant, it gives us 30 cm cube of carbon dioxide and 40 cm cube of steam, which makes up 70 cm cube of product. So the correct answer for this is option C. Similarly, we see in option D that 2 moles of C2H6 give us 10 moles of products which do not correlate to the information given above. Question number 39. 1 mole of magnesium is dissolved in excess aqueous ethanoic acid CH3COOH. How many moles of hydrogen H2 will be produced? To answer this, first of all, we can write down the equation between the reaction of magnesium and CH3COOH. So this gives us magnesium ethanoate. Since the valency of magnesium is +2, we see that we will require 2 moles of ethanoic acid. So this gives us, we see that 1 mole of hydrogen is formed. So the answer to this will be part B, which is 1 mole of hydrogen. Question number 40. The section of a polymer chain is shown. Which molecule would produce this polymer and by which type of polymerization? First of all, we see that there is no common linkage between the monomer units, and that there is a single monomer unit which is repeated n times. So this means that this is an example of addition polymerization. We can cross out options A and option C because they state condensation polymerization. Now if we draw the molecular formula of the monomer, we will have the following formula, and we see that this relates to option B because it shows the structure with C2H5CH double carbon bonds and then CH2. Hence the correct answer is option B.